Hello everyone, welcome to AI Anytime channel. So in today's video we'll see that how we can build an image caption generator app. So we'll be using a deep learning model, basically a transformer model, to perform this task where the input will be an image, and in output will get the caption for that image. Okay, so you can see that I have a cast ready here, and I'll be explaining you that how we are going to build this image caption generator app. So in beginning we'll be using a deep learning model to perform the task, and later on we'll be containerizing that deep learning model, and then all the application. So for application we'll be using Stringlit, and we'll also try to take this deep learning model and we'll try to build an API using fast API. So that way we can also use this AI as a service, right? So we call AI as an API, right? So how it's going to work? So we are going to use a encoder decoder model for performing this task, right? So as I said, my input will be an image, and then we'll perform some operation on that image, right? So an output should be a caption. So there are majorly two ways of achieving this task when I talk about deep learning. So either you take some data set of image and the respective captions and train a machine or deep learning model to generate the caption, right? That's the one way of doing it. For that you will need some kind of data set to train it. So there are multiple data set that you can use. Flickr 8K or Flickr 30K, for example, that you can use it. The other way is that you can use pre-trained model, and you will just try to use the weights and try to make some kind of prediction. So basically inferencing on top of those pre-trained models, right? So we can utilize couple of pre-trained models from Hugging Face, and then we'll try to perform the task. So in this video we'll be going with pre-trained model, and we'll try to see how we can use an existing model to achieve the task, right? So as you can see, I have an input image, and then first I will be passing this through an encoder model to get the encodings, right? So just to give you a brief, like for this kind of task, both natural language processing and computer visions are involved, right? So NLP and CV both are involved. So when you have an image, you first have to pass through an encoder model that can be uh, like Wheat or Swin, for example. There are many encoder models where you will get the encodings for your image, right? That the image that you have, that can be one image or the multiple images at the same time, will get the respective will get, let me bring my monitor up. You can get the encoding for that image, right? And when you have that encoding, you'll pass it through an autoregressive, let me write it here, autoregressive or decoder model. Decoder, right? So these are basically the language model, can be an example, and then you get the caption. So if you talk about the decoder model, the autoregressive or decoder model, there are many language models, right? So for example, we have RoBERTa, very famous language model. Then you have GPT-2, right? So RoBERTa, GPT-2, etc. Different decoder models can be combined with the encoder model to perform this task. So basically it's the infusion of encoder and decoder model to achieve this. This is a very high level flow that you pass an input image, and in return you get the uh, output caption, right? So this is what we are going to use. So you can see, let me bring my Colab. So we'll be using Google Colab today. Okay, and let me connect my monitor with this. Okay, so we'll see how we can use transformers to perform this task. So let me change the runtime to get GPU accelerator. You can use GPU, it works fine with CPU as well. Okay, it might take little time to do the inference. Okay, connect, and I'll be installing transformers. I'll do pip install. Okay, this one times. Let me do one thing. Let me go to increase the font size a bit. I'll make it 18. Okay, or maybe I can make it 20. Why not? So 20, and looks fine, right? So I'll do pip install transformers. Excuse me, and it'll take a little time. My screen monitor is still not up. Okay, you can run this locally as well. I'll be using Google Colab for this kind of task where I'm using a pre-trained model. So we'll use this and see how it's working. If it works fine, we'll try to take this pre-trained model and we'll try to build an API on top of this, and later on we'll try to use this API through Postman, or maybe we can integrate that into an existing or a new app that we are building in Streamlit or any other web or mobile application, right? So from transformers, import vision encoder and decoder model. Okay, and we need VIT. We need some kind of feature extractor, and we'll be using this feature extractor for the encoder model. And then we need the tokenizer. So we need the auto tokenizer. Perfect. And we'll be using PyTorch as the backend framework using import torch, and then we need below. So sorry, from PL import image. Excuse me, image. The import. Okay. So as imports are now successfully done, what we'll be going to do is that we are going to take the source from Hugging Face, right? So we are going to use a pre-trained model. Okay, so the links will be also given in the description. So we'll be using this Vite GPT-2 image captioning. Okay, as I was talking about, right? It's an encoder and decoder model. Okay, so for that, let me go back. Okay, and you can get the source from here. Okay, that NLP Connect. This is the source. You can also inference your sample images over here, right? You can try it out. Okay, so what I'm going to do, I'm going to use this a method that I have imported successfully, right? So vision encoder decoder model and dot from pre-trained. Okay, so dot from pre-trained, and then I will just give that source, that the Hugging Face source that we have. We do not need to give the entire Hugging Face URL, just pass it the excuse me. Okay, it will be downloading the model from there. It will take little time depending on your internet bandwidth. Now what I will do, I'll also download the feature extractor, right? So we need some kind of feature extractor. So we'll be using this V that we have imported ever, right? Feature extractor dot from pre-trained, and again that pre-trained, because we are going to use a pre-trained model, we'll pass this. Excuse me, I'm just passing this. Let me copy this. Next time we also need that auto tokenizer, so I'll just paste it there. And yeah, maybe I can just also define the tokenizer here. So I'll say tokenizer and then auto tokenizer, right? So auto tokenizer dot from pre-trained, and in this pre-trained I will just pass this copied Hugging Face source that I have copied from above, right? Auto tokenizer. You see that this model has been downloaded, the weights, etc., and this should do good. Let's see. So you can see that it kind of takes time to download the feature extractor and tokenizer from Hugging Face, and that is done, right? Now we can use GPU, but if you have single image and you just want to do an inference, it might take from few seconds to few minutes depending on the processing power that we have, right? But let's see how we can. So I'll say device, that you can get it on the Torch documentation as well. So Torch device, and then I'm going to say CUDA equal if Torch dot CUDA is available. Okay. So we are checking if CUDA is available, else use the CPU. Okay, and then we just pass model to device. Okay, so model dot to, and then pass the device. So what are we doing in this step is to trying to find out that if there's any GPU available. Okay, so if there's any GPU available which can use CUDA, okay, then that will be working as an accelerator. If not, then we'll use the CPU as it is, right? So model dot to device, and it will take, let me bring the CPU task manager here. How much is okay? So then we need to define few constants and then quarks and arcs that will define it here. So if you are not using PyTorch, okay, on your day-to-day deep learning activities, okay, you can explore about maximum length and number of beams, okay, and then how we can use those as quarks, right? So what I'm going to do, I'm going to say maximum length and define some value which is 10, and then number of beams equals 4, and then I will just use this get generate quarks variable, and then it's in a dictionary, so we have to pass this as a dictionary. So what I'm going to do, I'm going to say max underscore length equal colon max length, and good, and excuse me, and then we have number of beams. So number of beams equal num beams. Superb. Okay, let's run this. So we have defined some of the parameters, right, that we'll use when we are writing the function for the caption generator, right? So I'll just put define predict steps. Okay. So we'll use that function that you can also find on Hugging Face, which kind of takes the path of the image. So you can have one or multiple images there, right? So I'll just use that. It take your image path, and then we'll write the function within it. So we'll define a list, empty list that will contains all your images, and then we'll say for image paths in for image path in images path, okay, or image path, okay, and then okay, and then we just take an index of that image and image, and then we'll open that image. So excuse me, image dot open. Okay, image dot open, and we'll pass this image path here. We pass the image path. Good. What next? We can check if the image is RGB or not. So if image.mode, right, image.mode not equals to, okay, not equals to RGB, we can convert image dot image dot convert. So if we are checking that if that image is not an RGB mode, okay, then we can convert that using this convert method, and we can just pass. You can see it's accept this argument or the parameter which is mode here. So we'll say mode equals RGB. Okay. Then what we can do, we can, within this for loop, we can append this. So we'll say images dot append. Image. Let me see if this looks good. So what we are doing, so we are doing for image path in image path, and image equal to image dot open image path, and then if converting to RGB, if it's not, and then we are using this image as an input. Okay. That's it. What next? Then we need the pixels value, the encoding that we are doing, right? So if you remember, if I go back to this casting, sorry, the casting has been stopped. Let me sync up the casting once back. Let me see if I can pull this casting back. You can see it over here, right, that we have this image and we need to get this encoding, and then we pass it to a decoder model, the language model, or LLM, right, large language models like Robota or GPT-2, for example, right? So I have different devices connected with the main device that I'm using to write the code. Okay, so I have to suffer a lot today. Then we have images.append and then image. Then what we can do, we can have to get the pixel value. So say pixel values equals, we have to pass it to feature extractor, right? So the feature extractor, the variable that we defined above, and then we'll pass images equals to images, the images where we appended the image, right, in the above line of code. And then we have to return the tensor, and so we'll say return tensor. We are using PyTorch, we'll say pt, and then we need just the pixel value. Pretty much self-explanatory. So if we have been working with PyTorch, it will be easy for you to understand. This is not a PyTorch series, so I'm not covering those things. Maybe we can cover it in a separate PyTorch or playlist. So pixel values equal to pixel values dot to, and then it names this device. Okay, let me see. Okay, so then we had appended the image, and then we have extracted the feature. Okay, then passing images equal to images, return tensors equals to pt and pixel values. And then what we can do now, the output IDs, okay, for the images that we have. So output IDs equal to, we have to use the model to generate based on the pixels value. So pixel values, and then we have to pass that that we have defined the parameters above, right, with gen, what was that, yeah, here gen works. Okay, then we have got the output IDs. So what next? Pixel values, feature extractor done, then output IDs. Then what next is the, should be the predictions. So predictions threads equal to, we have to use the tokenizer. So tokenizer dot batch, and tokenizer dot batch, we need to decode. So batch decode, tokenizer dot batch decode. Just let me check what we have imported above. We imported auto tokenizer, feature extraction, include. Okay, fine. So tokenizer dot batch decode, and then we'll be using output IDs, and we can skip the special tokens if is there any. Okay, so we'll say skip special tokens, and then we'll just say true. So predictions done, and then we say predicts equal, then pass it to predict.strip, okay, which is the method, and then for in that pred in that ever variable that we have the predictions. That's it, and then we'll just return this spreads. I think this should do. So let me see. So we have wrote a function predict underscore step, and in that we have started with the image pre-processing, I'll say. Okay, that we are loading those images. We have first an list, empty list of images, and then we are finding out if that image mode is not equal to RGB. We'll convert those to RGB, and then we'll appending those images list that we defined above with all the input image that we'll have. That can be one or more than one also. Okay. Then we have the feature extractor for each image, right? And we are returning the tensors because we are using torch here, so you can see the TT, and then we are getting the pixel value. So we are getting the encoders, okay, and then we are passing it to the model to get the decoding done, and then we are just returning the prediction function predictions there, right? Let's see. Perfect. Let's run now. So what I will do, I have to see, I'll upload couple of images here. Okay, so I'll upload these two images. Okay, you can also mount this Colab with the Google Drive, so you can import all of your images or the data after mounting it with the Colab, right? You can use those drive folders or files, right? Similarly, it happens on the cloud notebooks as well. You connect with, if you talk about the SageMaker, you can connect with SageMaker with AWS S3, right? And similarly happen with GCP as well. We have Google Cloud Storage, and same thing with Azure as well, right? Similarly, also you can mount this Colab notebook with Drive, and then you can do it. Okay, so I'll just have imported it here directly in the runtime. So whenever you close this session or the session kind of gets finished, you'll not be able to use this images or the data anymore. Okay, so what I'll just do, I'll try to just use this predict function, predict underscore step, and I'll just pass this as a list. If you see above, we have defined. So I'm just saying I'll just pass one of the image first and see what it returns. As I said, right, it might take little time, few seconds. So it took around 8 seconds for this image. You can see it over here, right? And it's giving you a man riding a horse on top of a beach. If I open this, okay, image, you can see this image, right? It's a man, kind of what it says, what the caption that we received. A man riding a horse on top of a beach, working pretty good, isn't it? I really liked it. Let's do one thing. Let's try the other image as well. So I have one more, which is JPEG, right? So let me change the extension and see. So you can try with multiple images, or you can go and try with different images. I'll share that code with you. I'll share the GitHub repository of this code in the description. You'll be able to find it. So what I'm going to do now, let's see this image. Okay, and I'll just we'll save this image. You can see a tennis player, right? Kind of Rafa Nadal kind of playing some tennis shots, right? So you see a man holding a tennis racket on top of a tennis court. Amazing, isn't it, right? So you saw that how we kind of uh, created this model, use this model, I'll say. Rather, we are not creating a model here. Maybe we can also create a model. We can take the data from Flickr 8K or Flickr 30K. Maybe we can try when we complete this API, maybe we can capture in the third or fourth video. We can train a similar model and we can compare the performances of both this pre-trained model and the model that we will train. So in this model that you saw, right, what we did, we started with, we have an input image. We are using some kind of encoder model, and we are getting the encodings, and then we are passing it to a auto-regressive or decoder model to get the caption. So you see how both NLP and computer visions are infused together to achieve the results that we want, right? An image caption generator, a very powerful applications have been using image caption generator. Facebook, for example, suggests you some kind of captions, right? So a lot of organizations, basically in broadcasting, media, entertainment, they are using image caption generator. Okay, inbuilt with it, they kind of suggest you or recommend you based on the image that you upload or you were trying to post right before that. So what I'm going to do next is we are going to take this pre-trained model from Hugging Face, and we can directly take it from this Colab notebook now, and we'll try to use fast API. We'll try to build an API, okay, and that API can be consumed anywhere in an application. So this what we'll cover in our next video. So till now you can take this code, or you can take it directly from Hugging Face and try to uh, take some sample images and try to use this model and see how the performance is for your images, right? And let me know your thoughts in the comment box. I hope you like this video. If you like the content that I am creating, please like, share and subscribe the channel as well. Thank you so much.